Estamos still.
All right, we're live. So yeah, I haven't done one of these in a while. So welcome to another workshop, Moonbuilders workshop. It's really great to be here again. It has been a while for me, honestly, but yeah, we've had Kevin in the previous sessions, and he's done an amazing job. So my name is Alberto. I work at Developer Relations for the Moonbeam project, and today we're gonna do a workshop around XCM. So yeah, XCM has been the big headline of Kusama, mainly Kusama now this year. And so yeah, the idea is to do a little bit of a technical introduction. I don't consider myself like an XCM expert, so I'll do my best at providing the best concepts and the best examples for you guys. So yeah, I guess we can just go ahead and get started. By the way, I have these slides. You can find them in this bit.ly link, and I think Kathy will share it with you in the chat at the end of the presentation. And you can also interrupt me at any time on the chat or ask a question button. I'm happy to stop and just go ahead and answer the questions as they come. So let's start this journey together. So yeah, for today, I do always in my presentations, I do this like brief Polkadot introduction, but it's because I like to like set the context and explain a bit like, what Polkadot is. And in this case, I'm going to add a little bit of XCM. But the idea is to set the context so that, it's sort of like a self-contained presentation. We're going to also for sure talk about XCM. It's going to be an introduction. We're not going to do like a very, very technical dive into XCM, but it's going to be more like high level with some certain nuances and so on. Excuse me. And last but not least, we're going to do XCM on Moonbeam. What is our approach to XCM? That we're always focused on providing some sort of like Ethereum compatibility spin into things. And so we're going to see how we did that for Moonriver. How is it going to be for Moonbeam? So with that in mind, let's do our 30 seconds to 1 minute introduction to what is Polkadot. And so the main Polkadot idea is a specialization in connectivity. There's no one blockchain to rule them all. So the idea is that there are many best blockchains in this space. And Moonbeam is just one of these blockchains in an ecosystem of blockchains, right? So Polkadot, it is sort of like a central hub. It is also called the relay chain or layer 0. And it's a blockchain that it specializes in connecting other blockchains and providing sort of like as a service, like security to the whole network. So there's a certain relationship between the blockchains that connect to Polkadot and Polkadot itself, where Polkadot can guarantee via its economic model that the blocks that are produced by these other blockchains can be verified and finalized by Polkadot. And so these other participants in the networks are called parachains. The term comes from parallel blockchains. And the idea is that these are these specialized blockchains that provide specific functionalities to the ecosystem. So the idea, for example, in Polkadot is that you'll have privacy parachains, storage parachains. And in that sense, you have Moonbeam, which is a smart contract parachain that provides, as you might have guessed, smart contract functionalities. And so there's a certain like very interesting thing about this arrangement is that Polkadot is nothing without the parachains because there's no like real functionality to the end user, but there's also like the parachains themselves are nothing without Polkadot, right? So there's inherent trust that needs to be like the parachains need to have on Polkadot because Polkadot is providing a service, which is block finalization. And on top of that service, XCM actually, it's what allows different parachains or participants of the ecosystem to communicate with each other. And so XCM, if you're already trusting, let's say in a certain way, a certain degree, the relay chain, you can also like trust the relay chain to pass certain messages or verify certain messages and so on. And XCM is sort of this feature that allows all the participants of this ecosystem to communicate with each other. And it's where we're going to like discuss today and do like a light dive into it. So I guess we can start with the XCM technical introduction. And sorry that I'm just like getting out of a cold, so I'm going to need to drink water a bit during the presentation. So like I said before, I don't consider myself like an XCM expert, But the idea is to provide, certain concepts and demo you guys how to build an XCM message and our Moonbeam approach to it. So the first thing is, what is an XCM? The important difference is that it is not a protocol, right? So XCM is not, I communicated with this. It is just the message itself. It's a format for, thanks for the water bottle. Yeah, it definitely is. It's amazing. So yeah, it is a format. It's not a protocol. And one way that I like to see it, even though this might be wrong, it is basically like you can think about as email, right? When we write an email, a format email for sure, is we write it with a certain format. And so basically we always have like a small introduction, let's say the Magenta blockchain wants to communicate with the Cyan blockchain. And so it's like, hey, blockchain, dear blockchain, how are you? We have not talked in a while. You have the body of the message. And then you have sort of like the outro of the message, write me back, I miss you, whatever. And then you have the firm, like the basically the person saying, who sent the message. And so in emails, we have certain formats. And the idea is that XCM, it's a format of a message that can be used for that two blockchains can talk with each other. And two blockchains and two actually consensus mechanisms as well. So you will find a lot more information and a lot more details in the bottom link that you can see at the bottom of this slide. But the idea about XCM is that it's very generic. It's not really too constrained in general. It is compatible with different fee-based systems. So you have like gas chains, you have fee-less chains or whatever. It is also compatible with systems that you don't know the transaction format, and it's meant to be highly efficient, meaning many chains, many platforms. So the idea is that it's a very performant system, that it's able to generically communicate different consensus mechanisms, different blockchains. Like I said before, you can read more about it in the URL that I'm sharing at the bottom of the slide. The important thing to understand about the XCM is that XCM by itself, like I said, it's just a message. And so there needs to be some sort of like XCM tech stack around the message itself. And so we're going to see this tech stack from the user to the protocol. So this is an image that I grabbed from the URL from the previous slide. And you can see here, the user would be at the top here of this tower. There might be a like intermediate layer called like dApps, but the user is basically here at the top. And you can see that there's certain steps that needs to be done in order for an XCM to fully fulfill this sort of like end goal, right? So basically the user will interact, everything starts with the business logic, where there are these substrate palettes, which are these modules that you plug into substrate-based blockchains, or for example, smart contracts as well. And this is basically how the user interacts with the whole like tech stack. The next steps are XCM interfaces. This can be like the XCM builder palette, the contract environments, built-ins, and precompiled, and so on. So this is actually how the XCM it's built. But this is not how the user interact with the XCM itself. This is what builds the XCM out of the user interaction. Then you have the XCM itself, which once again is the message that is being sent. And the next step, it's sort of like how a lot of people confuse this XCM, is that there is XCM, which is the message, and there is XCMP, which is one of the ways that the message moves from A to B. So there are the different transport protocols that it can be: XCMP, VMP, bridges, custom relays. It's just a way for the XCM to move from a point to another. Last but not least, we have the consensus environments. They can be the parachains, the relay chain, the solo chains, whatever consensus environments there is, it can be added into this group. And this is where the XCM gets executed. So you have from the user to the consensus mechanism, how the whole sort of like thing works so that an XCM gets to the point where it can be executed. If you want to read more, like I said, there's this great article on the Polkadot wiki, but this is just to understand the different moving parts. And inside here, we'll do a little bit of the business logic, and we'll do a little bit deep dive a little bit into the XCMP and VMP to explain it, and we'll see some events related to it. So In terms of transport protocols, we have, like I said before, on Substrate, only VMP and XCMP is used. There is no relay, custom relays, or bridges. And so VMP stands for vertical message passing. And this is the way that the parachains, remember that the parachains are these blockchains that connect to Polkadot. The parachains communicate with the Polkadot itself. And so if Polkadot wants to send a message to the parachain, you will have a DMP. And if if Moonbeam wants to send a message to Polkadot, you will have an UMP, which is upward message passing, and DMP, it's downward message passing. So there was actually a good question in the chat that it's the meaning of XCM, and sorry that I did not set it. It has started being cross-chain messaging, but they actually changed it recently to cross-consensus messaging, because the idea is that, like Kevin said, the idea is that it can communicate different consensus and not only like different chains. So that's what XCM stands for. So in the case of XCMP is the way that two parachains communicate with each other. And so XCMP stands for cross-chain message passing, or it could be cross-consensus message passing. I'm not even sure what is like the up-to-date term. But the idea is that the way that two parachains communicate with each other is via the XCMP transport protocol. So XCMP works by basically sending the messages directly from one parachain to the other. Okay, how this happens is that the collators, which are the block producers in the parachain environment, will put the XCM in the outgoing queue of their XCM queue. And so other collators in the other parachains will start scanning all the collators in the ecosystem to see which one has a message directed to their parachain, right? So let's say I'm a collator in Moonbeam, so I would just raise my hand saying, hey, I have a message, an XCM message for parachain 1000. And so the other collators will scan around, and when collators from parachain 1000 will see that I'm holding my hand with my message, they will just say, okay, this is for me. They will grab it, they will take it to their parachain, and they will execute it there. In this case, the relay chain only acknowledges that a message was passed by storing, I think it's like a hash of the message on the relay chain block. However, currently, the XCM, full XCM implementation is not yet ready. And so there is like a stopgap solution called HRMP, which is horizontally relay routed message passing, which the idea is that the message itself, instead of being sent from a collator to another one, it is sent from the parachain, the origin parachain, to the relay chain, which, excuse me, which stores the full copy of the message on the relay chain block. And then this is then sent to the other parachain. The problem with this setup is that it's quite less performant, because it is not that scalable, because when we're sending 100 messages or more, that is not as scalable in terms of the relay chain. So it is a temporary solution that it's only being implemented while the full XCM transport protocol is deployed. So I brought some examples, like high-level examples of how XCM is being used, and this is actually true right now on Kusama. And this is, for example, to transfer assets. There are two main ways right now that people are transferring assets on Kusama. One of them is via what it's called asset teleporting, and the other one is what it's called remote transfers. So asset teleporting I like to see it as a burnt min mechanism, where in some Ethereum bridges uses this mechanism as well. But basically the idea is that when you want to move some dots, and let's say KSMs, right, from Kusama to Moonriver, what happens is that these tokens will get burned, and then this is done. The token burning is done by the XCM itself. It's not like a person will just transfer the tokens to like an empty account. Oh, I burned my tokens. That is not how it works. It works, the XCM itself, and execution of the XCM will burn some tokens on the origin chain, and then the destination chain will check and verify that these tokens are burned, and it will just mint new tokens to the target account. Once again, because tokens were burned on one side of the blockchain of the XCM, let's say, the newly minted tokens are like a perfect representation of that origin token. So this is like a burnt mint mechanism. This is actually being used right now on Kusama with StateMine, because they both use the same token. They both use KSM. And this requires a little bit of trust if you think about it, because let's say this parachain is malicious, right? And so all the people in the parachain vote to create 100 million dots out of the nowhere, right? So they could actually then send these dots back to Polkadot, and then that would be like an attack vector. So there's a certain degree of trust with asset teleporting. And in the case of StateMine, it's because it is a common good parachain that is not really owned by anyone. And so this will not happen on StateMine. In remote transfers, the story is a little bit different. And it's the way that this works is like these Ethereum bridges that are like lock mint, burn on lock mechanisms. So they're like probably the most common bridge implementation on Ethereum and other chains is that you lock your tokens on a smart contract on one side, and then you're like some tokens are minted on the other side of the bridge. And then if you want to go back, you destroy this minted tokens, and then you get your tokens back on the origin chain. How this happens on XCM is basically that the tokens are not locked in a smart contract, but they're sent to what is called a sovereign account. And I'll explain what a sovereign account is in the next slide. But the idea is that they're transferred to a special account called the sovereign account. And then what happens is that the parachain, in this case, Moonbeam, this is all done, like I said, via the execution of the XCM itself. We'll check if the tokens were locked, are held in the sovereign account, and they will mint a new asset, a new representation of these tokens, and give it to the destination account. So one important difference is that these new tokens are not the same as this new blue tokens are not the same as the pink tokens. They're like a piece of paper saying, hey, these assets are held in this other account in this other chain, compared to the asset teleporting. But when you send these tokens back, what's going to happen is that you're going to get the origin tokens back, all right? And we'll see some examples in the future. So the sovereign account, what it is basically a parachain-owned account in another parachain or even the relay chain. So Moonriver, for example, has a sovereign account on Kusama, and it has a sovereign account as well on StateMine. And like I said, it's an account owned by the whole parachain itself. It's not owned by one individual or by two or by three. It is held by the whole parachain. So there is no real control over this sovereign account. And so the idea of the sovereign account is that it holds some funds that are being sent. So it's like, one way that I like to see it is like the smart contracts where the tokens are locked. It's similar to that. And the address of this sovereign accounts is deterministic, right? So for example, this part of the right-hand side is the code that you can calculate the sovereign account of the parachain on the relay chain and the sovereign account of a certain parachain on other parachains. And it looks like a lot of things, but basically the main idea is that you encode the word para from parachain with the parachain ID, and you add a bunch of zeros until you get the number of bytes that it is 64 bytes. So you add all the zeros needed so that it has the correct length. In the case of the other the parachain owned account on other parachains, you encode the word sibling from SIBL from siblings with the parachain ID, and then you add the necessary zeros. What this means is that I created this tool that you can find in this GitHub repo, where you can calculate a sovereign account address for like a specific parachain ID. So for example, for Moonbase Alpha, the sovereign account of Moonbase Alpha, which is our testnet, on the relay chain of our testnet, is this value right here. And Moonbase Alpha's sovereign account or on other parachains of our testnet is this one right here. And in the case of other parachain accounts on Moonbase Alpha, what we do is that because we use Ethereum style accounts, we just truncate so that it has the same length as Ethereum addresses. So this is basically a 40 hexadecimal characters. All right. So you can do this, for example, for Moonriver, if you put 2023, and then you have the sovereign accounts of the different elements here. I'm gonna drink some water. All right. So some examples, right? I guess this helps illustrate a little bit how this works. Let's say Alice on Polkadot wants to transfer some dots to Alice with the TH on Moonbeam. How would this work, right? Via an XCM, like I said, everything is done via an execution of an XCM. Alice will transfer some dots, the amount of dots that she wants to send, to Moonbeam sovereign account. And then what's going to happen is that on Moonbeam, some new assets called XE dots are going to be minted and they're going to be transferred to Alice, right? So it's super simple if you explain it that way. Let's say Alice, she uses her XE dots to, send them to a friend called Charlotte, and then Charlotte wants to transfer these assets back from Moonbeam to Polkadot. Via the execution of the XCM, Charlotte is going to burn these XE dots, and then the Moonbeam sovereign account is going to acknowledge that Charlotte burned these dots, and the Moonbeam sovereign account is going to transfer the same amount of dots to Charlie, which is the account that Charlotte specified. All right. So there are little nuances here. Like, for example, there are some fees that are deducted from these dots. So if Charlotte sends 1, he's going to get like 0.99 or 0.98 or something like that. But the main idea is the same. You can imagine how this process is from a parachain to another parachain. The main difference is that the other parachain has a sovereign account on Moonbeam for this example. And the XCM execution, what happens is that Alice transfer, for example, glimmers to the parachain sovereign account, and then some other assets are minted in the target parachain. Going back is the same case as before, so we're not going to go through them. But this is more or less to explain at a high level how these asset transfers actually happen. All right. So more on XCM is how to open a channel, right? So before we start, super exciting to start sending assets here and there needs to be a channel that needs to be open, right? And this is a two-step process. And so basically the idea is that XCMP channels are, and in this case it's HRMP, right? But it's what allows the parachains to actually communicate with each other, or actually the parachain to communicate with the relay chain. But there's a nuance that I'll cover in a bit. So basically channels are one way. So if Moonbeam, for example, wants to communicate with the storage parachain, it has to open a one-way channel. But if the storage parachain wants to also communicate with Moonbeam, it has to open another one-way channel, right? So for back and forth communication, 2 channels must be open. When a parathread, so when a project connects to Polkadot as a parachain, there is already a channel with the relay chain established. That's by default. It's a 2-way channel. You don't have to open it and then get accepted or whatever. However, to open a channel from a parachain to another parachain, you actually need to do it via either governance or sudo. This is done because you have to do it via the root account. And what the root account is basically, it is in parachains that don't have sudo, which is the case for Moonriver and Moonbeam. It has to be done via governance. Or, for example, in Moonbase Alpha, because it's a testnet, we do it with sudo because it's a lot more straightforward. This is to request a channel opening. And then the acceptance of the channel. So it's a 2-step process. So Moonbeam will have to say, hey, relay chain, I want to open a channel with this storage parachain. And the storage parachain has to tell the relay chain and say, hey, I want to accept this channel opening or whatever. All right. And that has to be done as well by root, meaning that this is governance or sudo, for example. So that, the channel opening is basically done by building an XCM message. And the XCM message is actually super interesting, but because it's only the message itself contains multiple elements. And one of these elements is actually the parachain buys some execution time on the relay chain itself. So it's basically, it's like, hey, relay chain, I want to buy some execution time on the relay chain on you, so you can execute this XCM, this XCM request, which is basically open a channel. All right. And the channel you're going to open is going to be with parachain XYZ. The maximum number of messages I want you to have in this channel is 1,000 or 8 or 10 or whatever. I'm not sure what's like the default number. And the message size, it is, let's say, 1,024 kilobytes. I think that's like a regular message size. The interesting part is that the message itself is doing multiple actions, right? It's saying, I want to buy execution. I want to execute this transaction, which is the opening of the channel, and I want to pay for the fees and everything. So it is a pretty complex message that it's being sent. The other parachain has to also build an XCM message where it buys execution on the relay chain, and it says, I want to accept the channel coming from XYZ or whatever, right? So like I said, it's a two-step process. 2 XCMs need to be sent to the relay chain to open this channel of communication. All right, the last step before we go to the demos is going to be, oh, there are actually 2 questions. Let me see them. There you go. That's a good question. I'm actually gonna, so the first one is, why do XCM transfer tokens have the XC prefix? Is there any technical reason for this, since XCKSMs and KSMs are interchangeable? That is a very good question, Vale or Vale. Sorry if I'm not pronouncing it right. And you actually, we'll actually answer this in this next slide, right? Okay, the second question from Carlos, can you transfer XC assets between parachains? Example, if I mint an XC dot going from Polkadot into Moonbeam, could I transfer that XC dot into A star? And if so, how do you guarantee that the A-star account will have the dots? All right, this is a really good question, Carlos, and I can answer it right now before we go to the next one. So, and then we'll go to your account, Vale or Vale, sorry. So Carlos, the thing here is that when you're going to transfer assets, it's not as easy as I have the channel, I'm going to start transferring assets, right? There, in the case of Moonriver, for example, because you touched the point of, well, actually you said Moonbeam, but I'm going to use the example of Moonriver. When we started accepting KSMs, we had to register an asset on Moonriver called XCKSM, and then we had to specify, okay, this asset is linked to KSM on Kusama, right? And so what happens is that for Shiden, let's say on Kusama, to accept XCKSMs, they would have to register XCKSM as an asset on their parachain, right? And so it's a little bit more complex, because that means that if we have a channel with them, we will be able to send XCKSMs to them, but they won't be able to send it back to Kusama unless they do this asset registration with Kusama. So it's a little bit more complex. I'm actually not 100% sure if all that movement is possible, but if it's possible, it's a lot of like asset registration that needs to happen all over the place, right? So because you have a channel, it doesn't mean that you can start transferring whatever token you want. There needs to be like an agreement on what token you're going to transfer, right? And they're like, that's another sort of part of the puzzle where you have to say, all right, we're gonna accept remarks, for example. Perfect. All right, when I get a message saying, hey, I'm transferring this amount of remarks, the parachain is actually charging the execution of the XCM in remark tokens, right? So I mean, that's why you send one remark and you get 0.99 or whatever. And then we have to decide, okay, what do we do with this remark token? Do we send it to the treasury? Do we burn it? Do we give it to a collator? So there are a lot of like little details that it's really hard for me to cover in like the span of 1 hour. But this is a really valid question, and hopefully at least I shed some light into, you know, the different elements that you need to consider for XCM and the channels. So that's a very, very good question. So for the other question, this is basically why I always use the XC prefix for the prefix for assets. And this is because we're always looking into this sort of like Ethereum compatibility spin or solution for everything related to Substrate, we sort of created, and I'm like air quoting myself, there's another question. I would explain to that in a bit. The XC20 assets, right? So XC20s is a term that we invented out of the blue, but it refers to substrate XCM assets. So this is substrate assets created with a palette, with a runtime or whatever, that have an ERC20 interface. And this is the beauty of this is basically our solution. And the beauty of it is that because it has, you can access them via an ERC20 interface, you can actually use Hardhat, Truffle, the Web3 JavaScript library, Ether.js, even MetaMask to interact with this XC20 token. Even though it's not like an ERC20 deployed on the EVM, it lives under the Substrate palette. It is actually, you can interact with it as it would like an ERC20 token. So that's the beauty of it. And the cool thing that we've seen is that on Moonriver is that we've seen XCKSM and XCRemark, being put on DEXs, and they might pop up in lending protocols in the future. You never know. So I mean, I think the possibilities are limitless when you have this accessibility to XC, so substrate assets that are XCM enabled, basically from the Ethereum side. So this is basically our push to always provide sort of like accessibility to substrate functions or features from the Ethereum side. Another example of this is basically the staking palette, right? If you have ever used the Moonbeam dApp, you're actually interacting with the staking module, which is a substrate module, but you're doing it with your MetaMask without even really thinking what's going on. And that's basically our push, or what our developers always work on, is how do we do sort of like an Ethereum compatibility spin to stuff so that it is sort of like accessible via the Ethereum API. But that doesn't mean you cannot access it through the Substrate API, though. It's just that we are pushing more towards the Ethereum API. And so the XC prefix is just a way to represent that this is an XC20 asset, right? I mean, it is just like a lot of bridges, for example, on Ethereum like to add a prefix just to say, hey, this token, it's via this bridge. So it's sort of the same idea. There are a couple more questions that I'm going to get to. So can you explain how it works, the migration of Remark tokens to StateMine to Moonriver? It is the same on Moonbeam. Excuse me. So that is a difficult question to answer, because currently the migration of Remark tokens from StateMine to Moonriver is via like an XCM message that, I want to transfer this Remark tokens to Moonriver. And because we have the XCRemark asset registered, you can actually do it. But currently, there's a technical limitation on how a StateMine represents the assets that it holds, that you cannot send the tokens back to Remark. So specifically about the migration, I would definitely ask the Remark team. But how it works technically is that there's an asset on StateMine that can be sent to Moonriver via the HRMP channel that we open. And the cool thing is that because it's an XC20, you have seen them listed on DEXs, and people can swap them there and so on. The idea is that the same integration with Statement will be done on Moonbeam, but I'm not really sure if Remark will be on the Polkadot ecosystem. So yeah, I would actually ask the Remark team there with Bruno and all the team. Excuse me. The next question is, can you brief us about security while transferring the coins from one parachain to another? How to escape from exploits? Wow, that's a tough question for me to answer, because it is really hard in terms of security. Like I said, right, if you're trusting already the relay chain, the XCM message should be executed. There's certain specific scenarios where like the asset, it's not lost, but it's like froze in the middle of nowhere. And there's actually ways to recover these assets. But, developers need to be really careful when they build XCM messages. And I always encourage them to test on testnets so that they're comfortable enough to push these solutions to production. So honestly, that's a really tough question for me to say, because I'm not like an XCM expert. I would definitely ask like the Parity team and their element channels and so on. Last question, and I'm going to move to the demo right now. For those of us who want to build multi-chain protocols interacting with ERC20 tokens, are there any gotchas or code with XC20s that is Moonbeam specific that would not port over perfectly to other chains? Or are XC20s Yeah, so this is a really good question. So, excuse me. So remember that XC20 tokens are actually substrate assets, right? They're actually under the palette assets, which is, I think, is the same palette that StateMine uses. The XC20 part is that we actually provide a precompiled contract that it's an ERC20 interface, so you can actually interact with the palette, the assets palette, via like an Ethereum API. So I'm not really sure if there are any gotchas, because you always have the default of going to the Substrate API and the palettes, the palette assets directly, right? So I would say though that one of the main differences between an XC20 and an ERC20 is that XC20s are subject to governance, right? So I mean, it's really hard to say that this would happen, but if there's like a governance action saying I want to double the amount of this specific XC20, so XC20s are actually volatile to governance actions, right? So this is not the case for ERC20s that live in the EVM, but it's really hard to say because we would have to see how the XC20s evolve over the years and how are they used and so on. So I would say that in terms of building multi-chain protocols, these are substrate assets by themselves. But the XC20 just allows developers, because we're very focused on Ethereum developers, or if the developers that come and are familiar with these sort of tools, like I put on the slide. The XC20 is basically because you have the ERC20 interface to be able to easily integrate them into like EVM dApps and so on. So yeah. These have been really good questions, by the way. I'm super happy that people are asking these sort of questions. So, all right. I'm not looking at the chat though. I mean, hopefully, people are getting happy with their answers. So the other part of the Ethereum compatibility spin that we offer is the X tokens precompile. So the X tokens was originally a palette created by Akala, the Akala team. And so we're actually using that palette as well in Moonbeam and Moonriver. But we created a precompile so you can access these sort of tokens, this sort of like features from the Ethereum API once again. And the precompile offers two functions. So the first function is just like a transfer function where you have to specify the XC20 address, which is similar to like a ERC20 token address. Excuse me. You have to provide the amount. You have to provide the destination multi-location, and I'll explain what the multi-location is in a bit. And you have to provide the weight, which is sort of like the gas limit of the execution of the XCM, right? So it's like the maximum amount of time. I'm not really sure if like 1 unit of weight is like 1 millisecond or 1 nanosecond. I'm not 100% sure. But this is basically the amount of time I think you are allowing this XCM execution to have. That's why I think it's like sort of similar to the gas limit. So the multi-location, when you're actually starting with XCM, it's like a very hard concept to get a grip on. And it's sort of like the way that I like to see it is that if you're standing in the parachain, right, or wherever you're standing, and you want to get to another point in the Polkadot or Kusama ecosystem, it's like a way to describe the path that you're taking to get there. It is not easy, and we'll work through different examples to understand it, right? And the other function that we offer is very similar to the transfer function, but it's basically, instead of just saying the XC20 token address, right, like you see here on the example, you actually specify a multi-location that it's asset specific, right? So it's similar to the other multi-location for the destination, but it's asset specific. And these numbers might just seem crazy, but it will go through them, and I'll try to explain the best that I can so you understand what they mean. So a lot of technical jibber jabber, right? I mean, there's a lot of concepts that you need to digest. So I guess what we're gonna do is a demo. In this demo, we're gonna build a couple of XCMs, one to move tokens from the relay chain to our testnet, Moonbase Alpha, and then one to go back. And then we're going to do the same thing. We're going to go back from Moonbase Alpha to the relay chain using the X token precompile. And last but not least, I just want to show you might be familiar with this, but I want to show you the Moonbeam dApp, because it's one example. I'm not saying it's the best example, but it's one really good example of how developers can make this XCM craziness, as you would see, simple for end users, right? Because you're going to see how to build an XCM message. It is not really straightforward. So before I dive into like the demo, I just want to show you a little bit of remember the DMP, so downward message passing, that is from the relay chain to the parachain. And then the UMP, it's the upward message passing, that is from the parachains to the relay chain. So you can actually go to Subscan and filter. You go here and then you go to events. You select the module. So in this case, it's downward message passing queue, and then select the event that you want to check. In this case, I wanted to show you guys the execute downwards. And you can see all the messages that we've received. I think this is a little bit old now. It's like I haven't refreshed it in almost 2 hours. But you can see these are all the different messages that we've received only from the relay chain, right? And this other example is the different messages that the Kusama relay chain have received from other parachains. So you see this is Akala, this is the parachain 2001. I'm not sure if this is Bifrost or what. But there's the different parachains sending messages to the relay chain. All right, cool. Let's do it. I mean, let's build our first XCM message. So what I have here, this is the Moonbase Alpha ecosystem. So this is a relay chain that is where Moonbase Alpha, our testnet, is connected to. So I have an account here called Alice Relay, and we're going to send some tokens, some XC units, which is the token of this relay chain. We're going to send some units to Moonbase Alpha as XC units. So this would be similar to KSM to XCKSM, right? Because XCKSM, it's an XC20 token, you will see here that I have it added in MetaMask. Hopefully you see this big enough, but I have it added as a token in MetaMask, and I have a balance of 5.999, right? So what I'm going to do is that I'm going to send, for example, 7 units to Moonbase Alpha. In order to do that, I have to go here to extrinsics. And in here, I have to select the module that I want to interact with. And in this case, it's the XCM palette. So this is going to help me build my XCM message to transfer these tokens, right? So in the extrinsic type that I want to select, I have to go to reserve transfer assets. You can see here that you have teleport, which is one of the things that we discussed before. And the other one is called remote transfers, which in this case is reserve transfer assets. There are other options as well that you can play with, but I mean like limited teleport or limited reserve. But in this case, we're going to do this one. And you can see that we have 4 elements that we have to fill in. This is going to get a little bit complicated, but I'll try to like help you through the steps. So the first step is a destination. Once again, and this is a multi-location, as you can see. So once again, think that you're standing on the relay chain. So you're standing on top of it, and you want to get to a parachain, right? So the first thing is that we're going to use V1. And so the parent element, I like to see it as that, are you actually going through the relay chain? Are you actually on another parachain, and you're like, the first jump is going through the relay chain, so the parents would be 1 in that case. But because we are already standing in the relay chain, the first and only jump that we have to do is go from the relay chain to the parachain. So in this case, parents is 0. And then in the interior of the destination, we need at least 1 field to define our destination, all right? So this is like, I need 1 field, 2 fields, 3 fields, etc. So in this case, I only need 1 field, and that field is actually a parachain field, all right? And in here, I have to put the parachain ID of the parachain that I'm trying to get to, because this is my destination. You have to remember that this is my destination. So in this case, Moonbase Alpha, it's parachain 1000. Note that if this would be another parachain, so let's say state mine, and I want to get to Moonbase Alpha or Moonriver, I would have to say, okay, my first jump is going to the relay chain, so I have to put 1 here, and then I need an extra field to specify the parachain that I want to get to. But in this case, this is a 0. All right, now we have to define the beneficiary. And this gets a little bit confusing because this is another multi-location of the same type as before. So basically, the way that I like to see it is that for this particular XCM palette, we have to think that we are already in the destination parachain, okay? And one way to see it is because they're the same multi-location, but that's not really like necessary. But in this specific palette, we're already at the destination parachain. So in our case, we only have to say, okay, we're already there. We don't need to go through the parent. And I only need one field to represent the account that I want to send my funds to, okay? And in this case, it's not a parachain because it's an account. And what type of account is? And because Moonbeam uses Ethereum-style accounts, they're actually 20 bytes, so it's account key 20, all right? And what I'm going to do is that I'm going to put Alice's account here. Okay. All right. We have defined 2 of the 4 fields, and these were probably the most complicated ones, although actually this is pretty complicated as well. So assets, V1 again, and then we're going to add an item. You can actually add a lot of assets. Like, I want to transfer 2 assets with this XCM message. So I'm going to only do 1. And so right now we have to say, all right, we are in the relay chain because this is another version of X, like multi-location. In this case, it's multi-location assets. And so what type of assets do we want to transfer? So in this case, it's a concrete asset. I'm not 100% sure when to use abstract assets. I think it's when you want to define sort of like a bunch of bytes to define your asset, probably where it is and so on. But in this case, we want to use concrete. We want to use 0 because we're already in the relay chain. And we want to say here, because that is how the relay chain sees its own asset, right? So imagine, for whatever reason, the relay chain might see its own asset as, a general index 1 or something like that. Actually, for example, StateMine sees its own assets like general index 1, 2, 3. I think, for example, Remark, it's general index 8. But in the case of the relay chain, it's only here. That's how you define the relay chain asset. In this case, it's a fungible asset. We have not actually played around with non-fungible assets in XCM. And I said I wanted to send 7, but I need to add all the decimal places. So it's 12 zeros. All right. All right, we're almost there. And the last element of the XCM is the fee asset item. All right, so we are sending only one asset, asset 0. So this is the asset that we're going to pay the fee with. In our case, it's 0. If we were sending more, we could actually set this to 1 or 2 or whatever asset we want. But in our case, it's 0. That's it. We have our XCM. So let's go ahead and execute it. So I'm going to send this. So let's check. I think Alice had 6 X units, basically. So I'm going to sign my thing here. So let's go and see the Explorer, and we'll see, all right, XCM palette attempted, completed, balance withdrawn, all good. I'm going to go to the Moonbase Alpha. Oh, great. You can see down here already that we have some assets issued. So this is the minted XC units that were minted. You can see that it's almost 7 because there are some fees deducted. The downward message was executed, and then the downward message was processed, right? And if I go to MetaMask, you will see, voila, I have now almost 13 XC units. So we have sent an XCM message from the relay chain to the parachain. To go back, we have to do, once again, another transaction, in this case on Moonbase Alpha. And what I'm going to do, let's check first the balance of Alice Relay. So you can see that we have 39 units. Let's send, for example, 2 on the way back. So I'm going to copy Alice's address. And to go back, you might think that we have to use Polkadot.xcm, but we actually have disabled the Polkadot.xcm to be called by users. So in this case, what you have to use is the X tokens palette, like I said before. And the function is actually transfer multi-asset, all right? So you can see that we have, once again, 2 sort of multi-locations. The first one, it's a multi-asset multi-location, and the other one, it's a multi-location to specify the destination. This should feel a little bit more familiar, right? So first we have to define where is the asset, where's the origin of the asset that we want to transfer back. In our case, once again, this is like before, concrete, parents 0 here. The same as we did before here on the relay chain. It's because we have to say, hey, this is where this asset origined, okay? Where the origin of the asset was. Excuse me. Actually, this might be 1, actually, because we're in the parachain and we have to jump to the relay chain. I'm not sure. We'll check on that. And then we have to set the amount. So the amount, yeah, this is probably 1 because we have to hop to the relay chain and we have to say, okay, 1, now that I'm on the relay chain, where is the asset located? It's here, right? If it would be, once again, a state mine, this would be like X1, general index, and remark, it's like asset 8 or something like that. But in this case, it's here. Then we have to specify the fungible asset. I'm going to put 2 and 12 zeros. All right. And then we have to go to the destination, right? So the destination, once again, is where is this account? Where's the destination account? And in this case, we have to specify that we have to do 1 hop to get to the relay chain. And we have to specify at least 1 extra field, which is of type account. We have to know what type of accounts they use. The most general one in the Substrate world is account ID 32. And then we have to put here the account, which is Alice's account on the relay chain. All right. I think that's it. We have our asset defined as a multi-location, well, multi-asset, and then we have our destination as a multi-location. Hopefully I did everything correct. And the wait, like I said before, is the execution time that we want to provide more or less for this XCM message when it's processed. So I think for this example, 4 billion is enough. This is just a sample number. If you're going to do this in production, you have to check and make sure that this is the correct weight, because I think if this is not enough, your assets might be frozen in the middle of nowhere. So I'm not really 100% sure what happens if you don't provide enough weight. So yeah, you have to be careful with how you set the XCM message. So once again, I had 13 XC units and Alice has 39.8. So I'm going to submit this extrinsic. Let's check the Explorer to see when this transaction goes through. We should see some events here of like assets being burned and so on. You can see the events here already. Assets burned, some assets were destroyed, and some tokens transfer multi-assets event here. This is a message. So hopefully now if I go to the relay chain, you're seeing that I have almost 2 more units. So super cool, super exciting. I'm happy I didn't make a mistake while I was doing these XCM messages because it's super complicated. We'll still have some minutes, so I'm happy that I can show you the X tokens precompile. So the idea of the X token precompile, like I said, is to provide Ethereum API access to the sort of, excuse me, to the X tokens palette that allows users to send tokens from the parachain Moonbase Alpha or Moonriver or Moonbeam to other points in the ecosystem. So to get it started, you can go to Remix. You can load this address here and connect Remix to the injected Web3 provider, which will connect Remix to the network Moonbase Alpha here. And then what we can do is build our transfer function input elements, right? So the first input has to be the currency address. This is the ERC20 address, more or less, right? The token address of this XC20, which in this case, it's this one right here. I have it. You can also check it out in MetaMask. If you go to here and then here and view assets in Explorer, and this will take you to a page in Moonbase Moonscan where you can copy the address. So the next thing I'm going to do is set the amount. Let's send another probably 2 units. So let's put 2 with 12 zeros, which this should have. The most complicated element of using this precompile is a destination, because it's a multi-location, but you have to define it like in Solidity, which is not great. And so I'm going to explain to you how to do it. And last but not least is the weight, which in our case is going to be 4 billion once again. And so we're going to do is build a tuple, which is probably the most difficult element of this whole call. So a tuple is defined with square brackets in Solidity, and then the first element, as you can see here, it's a uint. So this is basically one number that defines if the parents is 0 or the parents is 1. If you remember our XCM message, I do have a copy here to help us out. This is you can actually copy this encoded calls here, and the string6, and it tells you like what options I selected before. And so here you can see that the destination is basically, it was parents 1, and then the interior was this, and we're gonna define this in a way that it is understood on Solidity. So basically the first element, it's a number that we're gonna set to 1, and then we have to set then a bytes array, okay? And so the bytes array needs to include, if it's x1, if it's here, if it's here, x1, x2, x3, x4, the type of account, the type of network, and the actual account, all right? So there's a lot of elements that we need to include in this bytes array element. So how do we know if it's x1, x2, here, or x4? It is basically by the size of this bytes array, right? So if I leave it empty, if this is my multi-location, this means parachain parents 1 and then here, all right? X0, which is here. If we want to have x1, it means that this element will have a size of 1. So only one element here, all right? X2 will mean that I have 2 elements, and x3 will mean 3, 4, 5, so on and so on, right? So in this case, I only need one element to define my destination. And so the next thing we have to define, if it's an account ID 32 or parachain or what. So to do that, I'm actually going to do this really quick. All right. So we said that the destination was 1, was x1. And in here, we had to set parent account ID 32, right? So the first element of this selectors, let's say, is parachain. That would be element 00, then 01, 02, 03, 04, etc., etc. So the first byte, or 2 hexadecimal characters, will be the selector, which in our case is 01, because as I showed you before, we selected account ID 32. You might guess that the next element is a network name, but we actually did something different where the next element will actually be the account that we want to send the tokens to. So you might think, yeah, I'm just going to copy this account and I'm going to paste it in here and it's going to be perfect. But this is not the case because this is an encoded sort of like type account. So we need to find the hexadecimal value of that account. And in order to do that, I like to use this Sean Trabisi Substrate utility website. Sean is from the Parity team, and this is super, super helpful because, for example, you can grab this account ID and pass it to hex with this like super simple tool that he created. So the actual value that I need to provide here is the hexadecimal value of the account and not the account ID. So this would be something similar in Ethereum, like, providing the public address and not the actual account address, which is different. So the next element would be my account in hexadecimal number. And then the last byte would be the name or the network of the account. So in our case, we're using the first element. So the selector will be 00, right? So 00, all right? And this is my multi-location, basically, all right? So I'm going to get this out of the screen. I'm going to put it here. And if I did everything correctly, and we're almost getting to the finish, so I'm glad that I covered basically everything. We have 11 XE units. So I'm going to click here, transfer. I'm going to get a MetaMask pop-up. As you can see here, I'm going to confirm this transaction. And I should have roughly, almost 44 units by the time this transaction gets executed. All right. So this is, like I said, we were, excuse me, instead of doing this horrible XCM message via this interface, we did it with a not that great, but better sort of way of doing it with the Ethereum API. In case we want to do this, the main difference would be this tuple, which would be parents 1 and then here, right? So it would be basically super simple because it is parent 1 and then here, which is an empty array, as we mentioned before. All right, I got a confirmation that my XCM was sent. And so I have now assets, almost 9. And if I go to the relay chain, I have 43, almost, some fees were deducted, but I have my assets on the relay chain. So yeah, that's actually pretty cool that I was able to show you almost everything. The last thing that I wanted to show you is how we implemented this on the relay in our Moonbeam dApps. And so basically, you can see here that when users want to withdraw an account, it is super simple. It basically, you click here, withdraw, you select the destination chain, you select the amount, you put in the address. Where is this? Here, right? You put in the address and then you click send and MetaMask pops up. So it is a lot simpler after developers have done their work for end users to interact with the with everything. So yeah. I need to expand this, but I'm having issues. So yeah, it's my MetaMask is not being nice with me. But anyways, oh, there you go. There you go. So I should be able to confirm this transaction. And after this is sent, we're gonna see the same effect as before. So yeah, just to wrap up really quickly, I left in the slides the encoded calls for the stuff that we did during this exercise. I also did left the destination tuple for the parachain to relay chain or parachain to parachain. The parachain to parachain case is a little bit more complex because it's an X2. So we need to provide the parachain ID, which is the first 2 bytes of the selector, and then 8 hexadecimal characters defining the parachain ID. And this part is basically the same as before. So yeah, if you have any questions, feel free to. I think that we don't have time for any more questions, but I don't think there are any more questions. As always, if you want to contact us, feel free to visit our website, Twitter, write us in Telegram, and for more specific developers activity, you can visit our Discord and give us a message, send us a message there, and we'll be happy to help you on board to Moonbeam Moonriver, whatever your project is. So yeah, I don't have anything else for you. Thanks a lot for tuning in. Thank you for the great questions that you provided. There's one extra question. Let's see if we can cover it. Yeah, no, that's actually a very good question, Kami. So currently, because the sending tokens from other parachains to Moonbase Alpha, it is done only through like the Substrate API. Unfortunately, that is not supported by MetaMask, and so people have to do it via like Polkadot.js extension and so on. So for example, in the Moonbeam dApp, when you want to deposit functions from like an external account to Moonbase Alpha, you actually have to, use Polkadot.js extension like I have here in my computer. So yeah, it is a shame that you cannot bring tokens to Moonriver, Moonbeam, or Moonbase Alpha through MetaMask. But that is a limitation that we have right now. So yeah, that's a very good question as well. So yeah, thanks a lot for tuning in. I'm super happy to be back in the Moonbuilders workshop. Make sure to check our socials for the next workshop that should happen in a month's time. We'll see. And so yeah, thanks for joining and have a good weekend all.